Welcome back to my channel. My name is Prachi and today we would be working on the physical and chemical properties of hydrochloric acid. So let's get into the video right away. So students, I hope you can see my screen now. So this is part 5 of hydrogen chloride and we are starting with HCl acid physical properties. So if we talk about the color of this acid, it is a colorless acid. Like the gas was colorless, the acid is colorless also. When we talk about the smell, it has the same smell as HCl gas, that is a pungent choking smell. The taste is sour like most acids have. Physiological nature. So if by chance accidentally you drop concentrated HCl acid on your skin, it will cause major blisters, that is, it will burn your skin severely. So concentrated acid is corrosive in nature and causes blisters on skin. The boiling point is about 110 degrees Celsius. Solubility. It is readily soluble in water in all proportions. That means if you have concentrated acid, as per the requirement, you can make it as dilute as you like by mixing more water into it. Now, moving on to chemical properties, action on indicators. So the first is moist litmus paper. Now this you would have done like 1,000 times by now. So it turns a blue litmus to red. That is what acids do. Then if we talk about methyl orange, it converts orange color of it to pink. Phenolphthalein, if phenolphthalein is colorless, it remains colorless in the presence of acid as well. So students, moving on to reaction on metals. So reaction on metals is pretty simple. That as per the reactivity series, all the metals which are above hydrogen would easily replace hydrogen and combine with chlorine to give us their corresponding chlorides. Along with that, hydrogen gas would be eliminated. So what kind of equations do we get? We get NaCl plus HCl, Na plus HCl giving us NaCl plus H2, that is hydrogen. Same thing would happen with magnesium. So MgCl2 plus hydrogen gas, CaCl2 plus hydrogen gas, ZnCl2 plus hydrogen gas. So all of these metals are above hydrogen, easily able to replace hydrogen and combine to form chlorides with the chlorine that is there. An example of a metal which will not react with HCl would be copper. So copper plus HCl will not give you any reaction. Now moving on to action of oxides and hydroxides. Now this is pretty similar to the one that we just did. What would happen? Metal will replace hydrogen, combine with chlorine to form a corresponding chloride. What is left? Earlier only hydrogen was left. This time along with hydrogen we have oxygen left. So they both will combine to give you water. So we get metal chlorides, along with that we get water. So let's look at the reactions now. So we have Mg, that will combine with chlorine. So that will give me MgCl2. What is left? H and O, that will combine to give me water. The same thing would happen in ZnO. So ZnCl2 plus H2O, FeCl2 plus H2O. So this is ferrous chloride. Ferrous chloride. Moving on to Fe2O3 plus HCl. This will give me FeCl3 plus H2O. What is this? This is ferric chloride. Okay. Now next, in this case we'll get CuCl2 plus H2O. Along with that, now we have hydroxides. Okay. Now when we have hydroxides, we have NaOH plus HCl. Similar type of reactions would happen. In this case, you get chlorides of the metal and you get water as the byproduct. So what do we get here? We get NaCl plus H2O, In this case, we get CaCl2 plus H2O, ZnCl2 plus H2O, CuCl2 plus H2O. So these are the reactions for what? For reaction with metals and reaction on oxides and hydroxides of hydrochloric acid. These reactions are not balanced. I would like you to balance them and practice it. If you're not able to balance it, let me know in the comment section and I will help you out with that. Alright students, moving on to the third point, that is action on metal carbonates and bicarbonates. So if we try and take a look at this, we have a pattern going on here. That when we were talking about oxides and hydroxides, we had an oxygen. So we were getting metal chloride, and along with that hydrogen was combining with oxygen to give us water. Now let's look at this one. In this case, once the metal combines with chlorine, you are left with hydrogen and you are left with CO3. So what would happen in this case? You'll get water as well as you'll get carbon dioxide gas. So you don't have to learn the equations, just understand the pattern of hydrochloric acid, how it reacts with different compounds. So let's look at the first reaction. So I'll get NaCl, that will be my metal chloride. Along with that, my hydrogen will combine with one oxygen and gives me water, and I will get carbon dioxide gas. Let's look at the next one. CaCO3 plus HCl. I am looking for a metal chloride. So CaCl2 plus I'll get water. Along with that, I'll get carbon dioxide gas. Same thing in the next one. NaCl plus H2O plus carbon dioxide. Again CaCl2 plus water plus carbon dioxide gas. Okay, so what do we understand here? If we have carbonates or bicarbonates, in that case my output gas should be carbon dioxide. Along with that, I should get a metal chloride. So what is left? I'll get water of that. Moving on to the fourth one, that is action on metal sulfides. So in this case, what will we get? We'll get NaCl, metal chloride, plus water, plus sulfur dioxide as the gas, SO2. In the previous carbonates, bicarbonates, we were getting CO2. In sulfides, we'll get SO2. So NaCl plus H2O plus SO2. Same thing in the next one. KCl plus water plus SO2. In the next one, I'll have NaCl plus H2O plus SO2. So this is the gas that we'll get. So SO2 as the gas we'll get. Moving ahead to the fifth one, action on metal sulfides. In this case, if you see, you do not have any oxygen, so you're not gonna get any water in this. What will you get? You'll get metal chloride again. Along with metal chloride, you'll get H2S gas with that, because that is what we would be left with. So NaCl plus H2S gas. What is H2S gas? That is hydrogen sulfide gas. What does it smell like? It smells like rotten egg. You need to know these differences between the gases. So H2S is a rotten egg smell. Next, FeS plus HCl will give me FeCl2 plus H2S. Again, rotten egg smell. So now, moving on to the sixth point, that is action on thiosulfates. So you just have one example in here, that is Na2S2O3, that is sodium thiosulfate. So what is the difference between all sulfides and sulfates that we did? The two over here, sulfides and sulfides. The two over here, the discussion for that, and the one here. So the difference is that when we react this, we are getting all the same products like the previous reaction, but along with that, we also get sulfur as a precipitate. So let's look at the reaction here. So I'll get NaCl plus water plus SO2, and along with that I will get sulfur as a precipitate, a yellow compound. So yellow PPT. So since we have this particular reaction with sulfur as a PPT, this distinguishes the reaction of HCl acid with sulfates and sulfides and thiosulfates. So you can write this as a note. You can pause the video right here. You can note this down. This reaction distinguishes thiosulfates and sulfides as sulfur is not precipitated when sulfides are reacted with dilute HCl. So you can take a note of this. Moving on to precipitation reaction. So in general, our HCl, dilute HCl, does not react with nitrates, except it would react with lead nitrate and mercury nitrate to give us white PPTs. So let's look at the reaction. So lead nitrate, I have PbNO3 whole twice plus HCl, which will give me a chloride, that is lead chloride. So it will give me PbCl2 plus HNO3 acid. Okay, so this is the reaction that you will get. This PbCl2 is your white PPT. Similarly, when we move on to mercury, so mercury nitrate with HCl will give you Hg2Cl2, that is mercury chloride plus HNO3. This is also a white PPT. The white PPT of lead chloride will dissolve on heating. That means if you are let's say the reaction is happening, and if you continue providing heat to it, so your precipitate will first appear and then eventually it will disappear because it will get dissolved on heating. Therefore, as soon as the precipitate is appeared, you have to turn off heat to make sure that your test is complete. Otherwise, you will lose out the precipitate that is formed. So lead nitrate and mercury nitrate with HCl acid will give you lead chloride and mercury chloride as the white PPTs. Along with that, you will also get HNO3. If you get a question, that is, give a reaction in which you are reacting an acid and you are getting an acid. So this can be one of those examples because you have HCl acid here and then you have nitric acid in the products. So this can be one of the examples for that. You can write down this note. You can pause the video, write down this note if you are writing along. If you are not, you can find the notes in the description section after the video is done. So right now you can just listen and understand the video, and later on you can go through the notes. Let's look at this note. This says that dilute HCl does not normally react with nitrates. However, lead nitrate and mercury nitrate react with hydrochloric acid to give white PPT of lead chloride and mercury chloride. PPT of lead chloride dissolves on heating. So this is an important note that you can take a note of. Moving on to mercury nitrate. Moving on to silver nitrate. Moving on to silver nitrate with HCl. So what will we get? We'll get AgCl plus HNO3. So silver nitrate is something that you will receive. This is a curdy white PPT. This is not a very bright white PPT. So this is AgCl is also a PPT. We call it curdy white precipitate. Now this curdy white precipitate, it is not soluble in your HNO3, but it will dissolve in ammonium hydroxide solution. Okay, so what do we have here? The curdy white PPT of silver chloride is insoluble in ammonium hydroxide solution. Now this is soluble. The curdy white PPT of silver chloride is soluble in ammonium hydroxide solution and forms a complex salt called diamine silver chloride. This curdy white PPT is insoluble in nitric acid but soluble in ammonium hydroxide solution. And this you can take a note of. It's important that when it combines with ammonium hydroxide solution, it gives you diamine silver chloride. Okay, AgNO3 is also used as a test for hydrochloric acid. So AgNO3 is also used as a test for hydrochloric acid and chlorine ion for both of them. So what have we understood so far? Let's come back here in precipitation reaction. So we have understood that regular nitrates do not react with HCl acid, but dilute HCl does react with lead nitrate and mercury nitrate. When it does react with these two, we get two white PPTs, that is your lead chloride PPT and your mercury chloride PPT. Along with that, you get nitric acid. The lead chloride PPT that you get will get dissolved if we continue heating. That means as you continue the reaction, it may get dissolved and disappear and you won't see the PPT anymore. Moving ahead, we also have AgNO3, that is your silver nitrate. Your silver nitrate also reacts with dilute HCl. On reacting, instead of getting a regular white PPT, we get a curdy white PPT. This curdy white PPT is insoluble in nitric acid, but it is soluble in ammonium hydroxide solution. When it does dissolve in ammonium hydroxide solution, it gives us a complex compound which is known as diamine silver chloride. And this is also used as a test for hydrochloric acid. So students, moving on to aqua regia. Before we start with aqua regia, let's understand a few things. That is, there are certain metals metals which are non-reactive with majority of compounds. That is our gold and platinum. Aqua regia is that compound which can easily dissolve or react with gold and platinum. Okay, what is aqua regia? Aqua regia is a combination of nitric acid and hydrochloric acid. How much of both of them? So we have 3 parts of HCl and we have 1 part of HNO3. That means 3:1 ratio. So let's look at the first definition. A mixture of 3 parts of concentrated HCl and 1 part of concentrated HNO3 is called aqua regia. It can easily dissolve even highly unreactive metals, that is gold and platinum. And how does that happen? Okay, so what happens is we have 3 parts of HCl, 1 part of HNO3. They combine to give us nascent chlorine. When we have the nascent chlorine, that goes ahead and combines with gold and forms a chloride. So let's look at that. So 3 parts of HCl, 1 part of HNO3 will give me NOCl. This is nitrosyl chloride. Along with that, I'll get 2 parts of water and I'll also get nascent chlorine. We'll have 2 of water and we'll have 2 of chlorine, nascent chlorines. This is nascent chlorine. This nascent chlorine will go ahead and combine with gold. So let's say you have Au plus 3 of nascent chlorines. This will give you AuCl3. Similarly with platinum. So you will get PtCl4. This is gold chloride and platinum chloride. These are easily soluble. So these would easily end up reacting. What is the function for aqua regia here? Aqua regia is providing us nascent chlorine. Nascent chlorine goes ahead and combines with our gold and platinum molecules. Moving on, we have tests for hydrogen chloride gas and hydrochloric acid. So HCl gas possesses a very characteristic irritating smell that we already talked about. It has a pungent choking odor. So that is a very distinguishing characteristic for HCl gas. Then HCl gives us white fumes. We have already done this. It gives us white fumes of ammonium chloride when a glass rod dipped in ammonium hydroxide solution is held near the vapors of HCl gas. We did this when we were doing HCl laboratory preparation for the gas. So what happens in here is that you have a beaker. In a beaker, let's say you have HCl gas filled. So how do you check if the jar is full of HCl gas? You bring a glass rod near it. This glass rod is dipped in ammonium hydroxide solution and this gives us white fumes
white dense fumes of ammonium chloride. So let's look at the reaction. So ammonium hydroxide is what? It is NH4OH combining with HCl, which will give me NH4Cl plus water. So this is what you would get, and this is your dense white fumes. Moving on, silver nitrate. Now we just covered this one. With silver nitrate solution, both the HCl gas and HCl acid will give you a curdy white PPT of silver chloride. Okay, so let's look at that equation. We just did it right here. Okay, this one. So we can just take a look at this. AgNO3 plus HCl gives us AgCl, that is a curdy white PPT, plus HNO3. Now the fourth one is a greenish yellow gas, that is chlorine, is liberated when concentrated hydrochloric acid is heated with oxidizing agent manganese oxide. This one, the last equation, this one is important, and this one is also important. Manganese oxide, MnO2. Okay, a greenish yellow gas of chlorine is liberated when MnO2 is heated with HCl. So what do we get? We get MnCl2 plus H2O plus chlorine gas. This is your greenish yellow gas. You can take a note further. A greenish yellow gas, chlorine, is liberated when concentrated hydrochloric acid is heated with an oxidizing agent manganese oxide. This chlorine gas that is liberated, it turns starch iodide paper blue-black. Very important distinguishing characteristic for your chlorine gas. The chlorine gas liberated will turn moist starch iodide paper blue-black. Okay, so this is what we had to cover for the tests of hydrochloric acid and hydrogen chloride gas. So my dear students, this finally concludes our playlist for hydrogen chloride, and we end our session for the day. If you have any doubts, if there is anything you're not able to understand, please feel free to drop a text in the comment section below. The notes are mentioned in the description section, so you can easily find that. Please let me know which chapter would you like me to begin next, and I would look forward for your response. Please like, share, subscribe and follow along. Thank you so much.